Good morning, everybody. Thanks for tuning in to this morning stream here. We're covering the DoraHacks AEZ Quadratic Funding Round grant participants in the house. Right now, we have from the Cosmos Indexer team and Defiant Labs. We have yeah, go ahead and wave if you want. We have Dan and Peter, and then from the Roll Up is here as well. And then Serta from the Go Code Degen project, and also Dave from DAO. If you guys haven't been following along, have been a lot of community contributions. You can still vote at DoraHacks.io/AEZ vote for your teams. Today, we're going to go through demos of a few of the grantees here and what they're working on. I'm going to start off with Defiant Labs and their Cosmos Indexer. Dan. Peter.
Yeah, hey, thanks, Trevor. Appreciate the introduction. I'm Dan B. I'm the owner of Defiant Labs. We brought a couple of products like Sycamore Tax, and we run some validators. And last year, we got a grant from the Atom Accelerator DAO for the Cosmos Indexer. And it was a huge success. And we are looking to continue support for another year on it. And I wanted to show you some of the features that we're excited about and looking to raise funds for. I'll do a quick, let Peter do a quick intro of himself.
Hey, everybody. Yeah, I'm Peter. I'm the lead dev at Defiant Labs. Been working on indexing in Cosmos for a long time now, and we transitioned that into the Cosmos Indexer SDK.
Yeah, so basically what we've kind of built is a generic indexer that will allow anyone to quickly query whatever information is important to them on the blockchain. As you guys know, blockchains have lots of different information. A lot of times you don't need every single piece of it. You want to sometimes say like, hey, I only care about these 3 things. And our SDK makes that really easy. And we'll step through that. So at the basics, you define the data you care about. So you might say like, hey, I only care about IBC activity, or I only care about like governance activity. So you just finally scope what you care about. You point it to a node, and then the results from that node come back in a code-friendly way so that you can develop against it. And we'll go into a little more detail on that. There are a couple of big challenges with on-chain data. Lots of people have written their own indexers that have been usually very application-specific. Like, for example, we wrote our indexer that was very specific just to osmosis taxes. That took us like a whole year to write, just to create the Sycamore tax thing. So what this allows you to do is get rid of a lot of that work of needing to know how the data is structured, and we handle all that. You just kind of define a few things that you care about, and you get the results back. Kind of talked about the solution already right there. I'll be happy to share these slides with anyone who wants them. All right, let's get into the fun stuff. So the first application that was built on top of the indexer was for the Atom Accelerator election that just happened. So I'm going to pull this up real quick. So what we're looking at here is about 24 hours of development work. We basically said, hey, we care about these 3 governance proposals on the Cosmos Hub, and that's the only data we want to track. We just want to know when someone votes yes, no, abstain, no with veto. We're just recording all that data. And then we are displaying it in real time. So from the moment those 3 proposals launched, these charts were interactively indexing in real time. And you could see basically the results of the election. What's cool about this, in my opinion, is unlike block explorers, where you can see the results of proposals, the results of this election were not based on whether the proposal passed or not. It was based on some attribute of the proposal. Like, it was based purely on total number of yes votes. It didn't matter if there was vetoes. It didn't matter if the proposal didn't even reach quorum. It's just totally based on yes votes. So we were able to build this really quickly, which is really cool. I'm going to step you through a little bit about how it works in a second. Let's go back to the presentation real quick. All right, so little dev preview real quick of how it works. So as we kind of define this theme, you define the data that you care about. And I'm going to let Peter talk really quickly about the code and just how you define this data. Go ahead, Peter.
Sure, yeah. So we're going to quickly step through the code. Probably not the most interesting thing for a lot of people, but as an SDK, we wanted to make it as easy as possible to integrate with our indexer. So the basic gist of what you're looking at right now is the most simple main function that you can use when integrating with our indexer SDK. Behind the scenes, the indexer is working through a lot of the boilerplate for indexing purposes. So at the beginning, it's going to start pulling in your configurations. Then it's going to go block by block and pull in messages at a time. So quickly stepping through the code. At line 4, that's where we define our filters. This is going to completely reduce the size of the data set that you're interested in. So normally we are going to index all messages, but for this indexer, we're only caring about 2 IBC messages. And we've put in some friendly filter tools for defining these filters and reducing the size of the data set to something that you actually care about. At line 12, we have built ways to register custom models. This is how we get your custom databases into the database that's tracked by the indexer. And then after that, we can define our custom parsers. So the indexer has built a very friendly and easy to use parser interface that you can register with the indexer. When this parser is registered, it's registered at message types, and the indexer will happily pass the message to the parser for you to parse into your custom models. So while the indexer is chugging along behind the scenes, indexing the blockchain into the application, the indexer application specific backend shape, we have allowed a methodology to take the data that we're already indexing and then reformat it, reshape it, and index it in the way that you want. And you can see the registration at line 24 for those custom parsers. We're registering 2 custom parsers for receives and acts, and those IBC messages will be formatted and indexed in the way that you want based on your custom logic that you're injecting into the indexer.
Awesome, thanks, Peter. So yeah, that's the kind of the first pillar of defining your data and like what it would look like for a dev to come in here and define the data. Just to quickly recap, Peter basically said you can define the data, and in this example, we're just defining 2 different types of IBC packets: receives and acknowledgements. And then, yeah, can you talk a little bit about how we request from nodes?
Of course.
And then,
yeah. So there's a well-defined loop that we've been working with in indexing in Cosmos, where we enqueue blocks to process, then we request the data for the block through an RPC node. There's 2 pathways that are followed in this for the indexer currently. There's the block event pathway and the transaction pathway. What we were looking at previously was the transactions, but we have defined a process of getting block events, which are a wholly separate concern. But it's possible to index those as well. So following the chain, we get the data from the RPC node. The default data processing happens where we turn the on-chain data into the data representation that the indexer knows and can handle. At this point, we then also, if custom parsers have been defined, we will pass the messages and or block events to those custom parsers so that they can be shaped into whatever data the SDK user wants. Once the default data processing has finished, it then goes to the database insertion workflow. And at that point, the default data gets inserted into the database. And then we also call the data insertion methodologies on the custom parsers.
Thanks.
I'll talk about the custom parsers a little bit too, because this is kind of the meat of the indexer SDK. So we have defined a very simple parser interface that developers can use and inject into the indexing workflow. There's 2 main functions that are required for the interface: the parse message and the index message function. If you're not wholly familiar with some of the types that are in the actual code base for Cosmos SDK, some of this might not look familiar to you, but if you are, you'll see things like the message type, log message formatting, And you'll also see on the index message function a couple of our internal types, the GORM database, which is the package we use for database management, and then our own internal message and message event with attributes. So very quickly explaining what happens here. When the data gets processed at the second step of that workflow we just previously talked about, if custom parsers have been injected into the workflow, the parse message function will be called to shape the data and return it as you see fit. We try to be as generic as possible, so this function returns any data that you want and an error if you want to call out to some error workflow. Once the data has been shaped into the shape that you require, later on the index message, which is the database insertion method, will be called, where the data that you've parsed and shaped into your custom model will then be called on that data set so that you can insert it however you see fit. We thought this was a good balance between forcing developer behavior through an SDK and trying to be as generic as possible so that we could allow for any usage on these custom parsers. Is this me as well, Dan?
Yeah, I think this is the last slide for you.
Yep. So as you saw in the previous demo application that we built for the AADAO elections, this was entirely built on top of the Cosmos SDK or the Cosmos indexer. The default data that we track in the indexer is there's a lot more data that's default tracked, but the main ones to highlight are blocks and transactions and all the values inside of there. So we were making extensive use of the actual default indexer data. We then built extensive custom indexer workflows on top of the default indexer. And this involved using the SDK as it's intended, and then also just building in extra features on top of the indexer. So while we were making use of the Cosmos indexer, we were using the time spent not developing our own indexer solution to build extra features on top of the workflow through message passing and that kind of stuff for handling more complex interactions with the blockchain. So we took the default data set, we then defined our custom indexer workflows and started to fine tune those types of things. So the rest of the development time was spent building, like I said, fine tuning the custom parsers and other workflows inside the backend indexer application. Then building an API on top of the database that was part of the indexer workflow, and then building that front end application.
Awesome. Thanks for that quick dev peek, Peter. All right, yeah, so why support this initiative? We think that if people use our indexer, they'll be able to develop applications a lot faster in Cosmos that depend on data on blockchain. Again, just we'd like to highlight the elections dashboard. That was a very quick project that we were able to spin up in less than a day. And we are hoping to show you guys how to actually build apps and help with it. So talking about what we're trying to do, we're looking to raise around 60,000 US dollars. 35 of that is going to be towards all the dev improvements, which are focused mainly around custom chain modules. We right now support a lot of the common modules that are on all chains, like staking, IBC, bank send, slashing, all the common things. But lots of chains have their own custom modules, whether it be like the Osmosis Scam Pool, whether it be like the Cosmos Hub liquidity stuff. There's all sorts of new modules coming out on different blockchains. So we would like to start supporting the most common ones. A big one's going to be doing COSM WASM support, being able to just track smart contract executions on blockchains. We're looking for around 15K to host 5 different workshops. These workshops are going to be like 8-hour sessions where we work all day with a team of people, showing them how to build a sample application using the indexer. And then we're also looking to do 10K for providing around 100 hours of support to these people over the rest of the year as they attempt to build their own applications or responding to any bugs that they find in the application that we can fix. but yeah, we're putting a huge focus on trying to educate people on how to use this to accelerate application development in Cosmos. So yeah, that's our slideshow. I'm happy to answer any questions that you guys might have.
We'll give it a second for any questions. It doesn't look like I have any coming in right now, but I'm sure that people will be reaching out if they do have questions. All your contacts will be on the page.
Yes.
Thanks for that, Defiant Labs, and again the Cosmos Indexer. If you want to support this project, DoraHacks.io/AEZ. Go there, check them out, vote. Thanks for that, guys. Up next, we'll be going to the roll-up company. The roll-up company. If you want to go ahead and load in and pull your presentation up, we'll get going.
Yeah, happy to sound off on what we do at the roll-up. So I think this is a bit different from maybe some of the other presenters in this live stream. My name is Robbie. I run the roll-up. We are an educational company. And so we've been teaching people how to use applications on chain for about 5 years. We have a podcast. We are doing lots of things across very different verticals in the on-chain world. And so what we do is we have people, founders, builders on our channel to talk about their projects. Very similar to this live stream here. We invite people on. We talk to them about what they're building in the space and how they're contributing to bringing this technology and blockchain in general to the masses, billions, millions, and billions of people. And so I don't have a live demo today to show you guys some tech or code, but I can talk about what we're doing in the space and some of the things that we're bringing to the table. We feel that education is a real missing component when it comes to bridging the gap between these crypto natives and crypto curious people. And so a lot of what we do stems from our own passion and curiosity to learn more about this technology. Like I said, we got started in 2020. We started during DeFi summer over on Ethereum, and we started teaching people how to use DeFi applications on chain. Then we expanded to start really educating more on blockchain design and architectures with kind of like this Cambrian explosion, both of infrastructure as well as ecosystems. There's so many new options, and we've been big proponents of modularity as well, which leads to this unbundling of technology. And so now we don't have a lot of these monoliths kind of like building behind closed doors, building black boxes where there isn't much transparency. A lot of this is much more out in the open, which leads to a lot of innovation and experimentation all up and down the stack. And so what we've been able to do is dive deep into each portion of this stack so that we can deliver really deep and technical education for founders, builders, as well as some high-level conversations for developers in the space. And what we've seen is this touch both users at that far end of the spectrum and the crypto native innovators and builders that have been in the space for a long time. We mix up our educational stack with a few different series. And so this has been our regular deep dive into some different verticals that has really been an exploratory learning experience for my co-founder, Andy, and myself. And what we've seen is that by us diving deep into each of these topics, we're able to have this collective learning experience with the people that are on board. We like to profess that we're not experts in this space. It's tough for anyone to be an expert in multiple different areas. And so what we do at the roll-up is we invite experts in a very specific domain to educate us and then also educate our audience and our community that's watching behind the scenes. And then by doing that, we're all able to engage in this collective learning experience. We've had the podcast going, like I said, for 5 years now. It's eclipsed hundreds of episodes at this point with some of the top founders in the space, in the Cosmos world, Ethereum world, and most recently in the Bitcoin world. So we've got a Bitcoin L2 educational program that's going on right now. It's called Bitcoin and Beyond. And this was the third, this is the third installment of these educational series that we've been doing to broaden our stack of content. We started off with our ZK Academy last fall. And then after that, we moved on to Modular March, which was an entire educational program running the month of March. And this was talking to all kinds of builders and founders in the space that are building in this modular ecosystem. What we've been able to do is we've been able to learn about a lot of these projects. And one of the things that we find people all across the spectrum, both the users, builders, founders, and developers talking about is how difficult it is to keep up with all of the new things that are coming out on a daily basis in the industry. And so that's one of the gaps that we've been trying to solve, is bringing content to the forefront that is able to span both this technical and non-technical spectrum on a daily basis, and still maintain a high quality of work that brings a unique learning perspective to the table. And so I realize that a lot of times it's difficult to keep up with a lot of things in the industry, but if you're looking for a deep dive on a particular subject, whether that's ZK, modularity, Bitcoin L2s, we're going to do some restaking things and some chain abstraction things in the future, or you're looking for some more general conversations from some of your favorite projects. I'm sure we've had them on the show, and we really like what's going on at Cosmos at the intersection of modularity and scalability. I think there's tons of things. We've had a lot of conversations with Celestia folks, and then some people from the sloth community like Zaki have come on the show. We've spoken with Sunny from Osmosis. And so a lot of these conversations help to shape our perspective of how we see the on-chain world in general. And that spans Bitcoin, it spans Ethereum, Cosmos, Celestia, Solana, and all up and down the stack. And so that's the roll-up in a nutshell. I invite you to follow us on Twitter at the RollUpCO. You'll see it in that bottom left-hand corner of our profile here. And then also check us out on DoraHacks. Grants and public funding is how we support our channels. We do a lot of open source, public domain type work in collaboration with some research firms from each of these different ecosystems. And so yeah, I'm really excited, very thankful for DoraHacks and having me on this live stream today to talk to you guys. I hope this was helpful and productive, and I hope to see you in some of our community chats over on the Rollup. So that's about it for me, and I really appreciate this opportunity.
Awesome. Thanks for that. Thanks for that, Robbie. Another really great project contributing to our ecosystem and ecosystems beyond. Again, that's the Rollup. Don't forget to vote for them and contribute if you think that all of that made sense to you. I know education is really important, just across the board. All right, thanks for that, Robbie. Up next, we'll be going to Serdar and the Go Code Gen project. Serdar, take it away.
Yeah, I'll share my screen. Can you see my screen?
Yep, looks good.
All right. Yeah, so this is the demo for Go Code Gen. If you want to see the demo yourself and run it on your own machine in your own time, because I don't think I'll have the time to go over the full demo, you can go to Go Code Gen's repository, and then there's a link to the documentation. Also, I'll drop this link in the chat, so maybe someone can drop this on the chat. Okay. So what is Go Code Gen? Essentially, CosmWasm smart contracts are written in Rust, and a lot of the times developers need to interact with these contracts from Golang, whether it's because they're using an indexer, they're building a server, or they're using a test suite that's in Golang. And Go Code Gen essentially generates Go code for your CosmWasm smart contracts, similar to TS Code Gen that I think Confio maintains. Okay, so I'll quickly, maybe we can go over half of this, but I'll go over a demo of it. There's three main features of Go Code Gen. One of them is generate message definitions for a contract. The other one is generate a query client, a gRPC query client for a smart contract. And then I also added the last feature is the ability to generate an end-to-end test suite in Go using interchain test. And if you already know interchain test, it's a testing framework used by many core developers in the Cosmos ecosystem. And if you want to learn more about it, you can always read more context here. Okay. So again, yeah, there's several things you need to have in order to run this demo. Of course, Git, Go Code Gen itself, and there's I've released later versions since this tutorial went up. There's nothing wrong with using the latest version, which is 2.4 right now. Maybe 2.5 should come out soon. And Rust for compiling the contracts and etc. And Just is an optional make alternative that is very popular in the Rust ecosystem. Okay. So there is a workshop repository that you first clone into your computer. Here I've done this already, as you can see my terminal. And then what I'm asking you to do is create a new branch. So let's do that to run this demo. So maybe I'll just create a Atom Economics Zone quadratic funding demo. Okay. So what's in this? So if you just take a look at what's here in this repository, right now I just have a contract. Yeah. So in this repository I just have a contract. This is the CWICA controller contract that I've also joined the. That's also a part of this funding round, and you can also read more about it in its own page. But I will not go that much into detail. All we need to know is it's an IBC-enabled contract with complex message types. So it's a good example to show that even very complex contracts can work with Go Code Gen. And in this repository, we have two more testing contracts. So these are not a part of the main contract, which is CWICA controller. We have like a callback counter and the CWICA owner. So these are just testing contracts that are not supposed to be used in production or anything. Okay, so I guess the first thing we can do is the way Go Code Gen works. So if we go here, the way Go Code Gen works is it works with the CosmWasm schema files. So we first need to generate those. Here I'm compiling the contracts first. I'm not going to do this here because compiling contracts can take a little bit of time. But it's as simple as using Docker to compile the contracts. So I'm just going to generate schemas. Right now, I've already compiled the contracts in the artifacts directory. Okay, so this should generate the schemas. Yeah, this still takes a little bit of time, but I think it's good to go over this. While we're talking, yesterday I made a new release of CWICA controller 0.6, which is basically enabling you to not just do interchain transactions, but also interchain queries. This is enabled by the latest version of IBC Go. And you can read more about that release in CWICA controllers page. Okay, so it seems like we've generated the JSON files that will be used to generate the Go code. Now we can already quickly see what Go Code Gen can do. So let's just see Go Code Gen. You can see the version I'm using is 2.4, and let's do generate. So you can always press help to get help, but we can do generate messages. So I'm going to generate message definitions, and the way I select the contract I'm generating, I'm going to select its schema file. So it should be in schemas. So in schema, and then inside schema there's CWICA controller. So I'm going to select CWICA controller, and I should normally put an output. So where do you want to write the Go file, and like maybe a package name if I want to use a custom package name that's not auto-generated. But right now I'm just want to show that we can generate messages and not really use this for anything. So I'm just going to run this. You can see that there was a duplicate definition and it changed its name. It gave a warning that is fine. So if we go into an editor and go to messages.go, that's just generated. Obviously, there's an error at the top because this is not inside the Go file, which we will fix in the full demo. But you can see that all the message definitions are generated. So instantiate message, execute message, that's supposed to be an enum. And you can go to, let's say, send Cosmos messages, which is like another complex definition. So if you've used Cosmosm, the Cosmos message type, which is what is used to submit Cosmos messages as the contract to the chain. So you can see that those are generated since this contract uses Cosmos messages to execute transactions on the counterparty chain as opposed to the current chain, which is what Cosmos messages are normally used for. And you can see that there's the Cosmos message for bank, and then that's a wrapper around bank message. So this is basically generated the entire messages that you might need when interacting with this contract. So now we can remove this file since we have seen what the basic generation looks like. We could also generate a query client, but since I'm also already gonna do that while doing the test suite demo, I suggest we just jump to the test suite demo. Okay, so we just did this exploration to see what it can do. Next, we're gonna scaffold the test suite. So this is another command in Go CodeGen. So Go CodeGen interchain test. And then now you can do two things. One is scaffold and the other one is add a contract. We don't have a test suite yet. So the first thing we need to do is scaffold the contract. So I'm just going to say scaffold. This doesn't take any arguments because it opens up an interactive window for you to enter the variables. So, it's going to create a test suite that's going to be a Go project. So it wants a module name. You can. This doesn't really matter since this is not going to be published online. You're just going to use it for internal testing or pushing to GitHub. So we can just say just use the default settings for now. And the output directory, I'm deciding to put it inside end-to-end / interchain test v8 because that's the dependency we are using, interchain test v8 version. And a number of chains. So this is an IBC testing suite, so you can choose a number of chains to generate. So this is basically this test suite basically generates, runs validators and relayers on your local machine, or if you're using GitHub, then it's gonna run it in GitHub CI. So you can generate 3, 1, or 2. Technically, I think I could generate more, but I've not seen the usage for more than 3 chains so far, and I just think it's nice to limit functionality. So I'm just going to generate 2 chains for now because we're just going to do some basic IBC testing. And the last question is, would you like to generate GitHub actions? So this is, every time you open a pull request or every time you make a push to main, would you like the tests that you are going to have to run? And I'll say yes because I also want to demo that as well. Okay, so now this generated the test suite. It might take a little bit longer on your machine since it's also going to be installing the dependencies for the Go file. I already have the dependencies, so it was really fast. So now we can go into this directory. So it's inside end-to-end interchain test v8. You can see that if I go back to the text editor, we have a new directory called end-to-end and a new directory called GitHub, which includes a workflow file. So this right now there are no contracts in this test suite. It just has a basic test in it, and this basic test essentially just makes like a transfer, creates a transfer channel between the 2 chains. In this case, this WASM D1 and WASM D2. You can see that if you go to the chain config, you have 2 chains, which is it's using the Docker image of WASM D v50 and WASM D. And the other one's also a WASM D chain. Now you can customize these to be the image of Osmosis and the image of other chains. And there are, in the tutorial, there's examples on how to do that as well. But for this demo, I'll just keep them simple, WASM D. Okay, so now we are already good to run the basic test, which essentially just creates a channel from the relayer, and we verify that the channel was created, and then we transfer some tokens with the accounts, and then verify that the tokens were transferred. And you can see this test file yourself and understand how all these tests are done and how customizable it is. Okay, so let's run this test. So here's the command here should be the command to run the test. So this is inside the basic test suite. That's the auto-generated one. So let's just do that. So we're just running the basic test. Okay. So basically what it's doing now is it shouldn't take too long. Like it should be like, like 3 minutes at most, but we might not want to wait for all of this, but basically it's starting with the chains and taking the actions like that we said. So the first stuff is like creating 2 validators per chain and then initiating the relayers and then starting to make the transactions that we've seen. Now, I want to show that this also works in GitHub CI because I think that's an important part of the demo. So what I'll do is I'll push all this progress to GitHub. So let's say step 1 for the commit name. So we added all the changes. Okay, we didn't add everything. Oh, I want to make sure I added it. Let's amend our commit. Okay, now we added everything. So now let's push it to the actual GitHub repo. So I'm just gonna copy this and then push it to the GitHub repo. Okay, now that this is done and the test is running, we can quickly see that we can see that the branch is there. And if we just open a pull request, do not merge demo to create pull request. You can see that the end-to-end tests are running. So the thing that's running on my machine is also running in GitHub CI. And if there's any failure in the test, then this is gonna fail. So it already comes with a suite you can use for in your GitHub CI. And in CWSA controller, I use many such tests. So not just a single test, but many such tests to test a bunch of different cases. Okay, I guess I'll do one more thing and then we can conclude the demo, which is that adding a contract to the test suite, right? So because this contract didn't have any tests, any contracts in it. You can see that the test has passed, but let's add our custom contract. So what I'm going to do is inside the I'm saying go code gen, add contract, sorry, interchain test, add contract. And then I'm going to give the schema of the contract once again. So this should be schema CWSA controller. Okay, now it's added. So now if we go back to our text editor, there's additional files are added. There's a contract test and there's the CWSA controller package, which has all the messages that I showed you. It has a query client and it also has a contract.go, which essentially is an it has nice helper functions such as instantiate. So this way you can just instantiate your contract in your test suite. So now the final part of the demo here, we have a test suite that's basically not doing much. It's just instantiating with an empty instantiate message. So this would likely fail. Now what I have here is I basically have a full-fledged, I should have a full-fledged test here, right? Okay, maybe next one. Yeah, I have a full-fledged contract test file. So that's actually doing some real test on the contract, like channel opening handshake, this sends a delegate message using the interchain accounts using CWSA controller. So I'm just going to copy this thing. I'm going to delete everything here. I'm going to paste all of this. So maybe I'll just do it like this. Okay. So now, oh yeah, so because I imported some stuff, I just need to run go mode tidy. And this also says it on here. So once you paste this, it says you should run go mode tidy. Okay. Should be fine, I think. Okay, interesting. Anyway, I suppose maybe I broke the demo in the version 0.2.4 somehow, but okay. Yeah, I think maybe I'll make another push to fix it. But the idea that I want to show here is I wasn't gonna run the test because it's gonna take too long. I was just gonna walk over the test and then show how it works. I think, yeah. So yeah, this demo is about to end. But what I will say is that I just want to show the query client because that's the part we didn't get to. And the way it works is, okay, let's say I have a contract object and I get this query client. And the idea is that you can get this query client through other methods as well. So if you are actually running it, like building a server or building like an indexer for a contract, you can create this query client through this auto-generated query client here without using the test suite. That's the idea. So new query client, and then you give a change gRPC address, you give the contract address, and that's it. And once you have that, then you can just run queries like get channel, because that's a query that the contract has. And you can see that here, for example, get channel. Yeah, get channel. It takes a query message get channel and it returns the channel state basically, and it does like a gRPC query. Okay, that's pretty much it. And I'll see what happened here. But if you use the versions that are actually in here, the demo should work flawlessly. Like maybe I've changed the versions since I've run the demo. That I think that's it. The main usage of the contract, as I said, is not the test suite itself, but it's the actual generation of this message types. I think that's what people have found most useful, and the query client. But this the test suite itself is a nice addition on top of that. Anyway, thanks for watching, and that's it.
It always breaks when you're demoing it, doesn't it? when you want to show it. Something about it, but
I did show half of it, which is good.
we got through most of it.
Yeah.
So everybody should definitely check out your updates. Where can they find your updates when you do the new demo?
When I do the new demo, so as I said, I already put the link of the website on the chat. So if there's any updates, that website will just when there's any updates, that website will just change with the new versions of everything, the latest versions of everything.
Cool. So when you update everything, it'll just be live on there. Okay, cool. Well, thanks for that, Serdar. Always really stellar stuff that you're working on. Again, DoraHacks.io/AEZ. Go and vote if you think that sounds like it's what Serdar's working on is contributing to the ecosystem. It definitely is, but go cast your vote if you'd like. Up next, we'll go to DAO. If DAO, you want to jump on, and just a reminder, anybody who's voting, if you vote in regular quadratic funding and Macy, both of them, you get entered to win a bad kit when we do our raffle at the end of this. So make sure to get in. Dave from DAO, you're up next, buddy. You're muted. I still we can't hear you.
Sorry, pardon me. Presentation mode here. Share screen.
I was gonna say we can read lips, but not that well.
Yeah.
All right, cool. I'll leave it to you and share when you're
cool.
ready.
Yeah, can you see my screen?
Not yet.
Nope.
Not yet.
We there?
There we go. Looks good.
Okay. Technical difficulties. Thanks for having us. My name's Dave. I'm a contributor to DAO. At DAO, we build interchain governance and DAO software. There are so many features to DAO that I couldn't possibly go through all at one time. So I'm just going to highlight a couple of things and walk through setting up a DAO. To start, you can see that we are currently running on 9 chains. That's all from this year, and we're growing pretty fast. We've got a few other chains coming up, and we're securing $259 million of value in our treasuries, which is all audited code. So one of the cool things that you can do with DAO, and we don't talk about this maybe as much as we can, is you can go and you can vote on any proposal in any chain in the Cosmos. But not just that, you can create a new proposal, and it's all no-code software. You don't have to use the CLI, which is a pretty cool thing. Once you're logged into DAO, you get your own home screen and feed. You can log in with many different wallets. And let's get this here. And so you get a feed of all of the proposals that you have from the DAOs that you've subscribed to. And so today I'm going to walk through just creating a new DAO, just so you can see some of the different configurations that you can do. This is a new DAO. So we've got three types of DAOs. You can do a membership DAO, which is like a multi-sig. It can be anywhere from a 2-person multi-sig to, I don't know that there's an upward limit. I haven't tested it, but you could go for thousands, hundreds of thousands, I presume. You could also do a NFT DAO, so that anyone holding an NFT or staking an NFT is a member of the DAO, or you can create token-based DAOs, where you create your own token. Currently CW20, but we are, or I guess it depends on the chain, is Token Factory. I'm going to create a membership DAO just to show you some of the things. And I did this a little bit earlier so that we wouldn't have to load it. But you can add, you know, any number of contributors. And in this example, they all have the same voting weight. If you wanted to, you could add a different tier and change the voting weight so that they could vote differently and have more power within the DAO. I forgot to mention, if you look up here, you can create a DAO on any of these current 9 chains. I'm sticking with Juno for now. And once you've added your members, you can go into the interesting stuff. So you have things like voting duration, how long you want the proposals to be voted on for. You can have a deposit or not. And then you've got multiple choice proposals. And, you know, you've got an option of either having your standard yes, no, abstain, no with veto, or these multiple choice proposals you can configure to run any code if that option gets chosen, which is pretty cool. You'll see that in the advanced settings, there is a warning because it is pretty easy to which is the number of individual votes, or sorry, the percentage of individual votes on an option. You've got quorum, how many people you want to come in and vote on the proposal to make it a valid proposal. And then allow revoting. Allow revoting is a pretty cool thing where if it's turned off and you have met the quorum and the passing threshold, then you can execute that proposal early. Pretty cool feature. And then we get into some of the things like approving or vetoing a proposal. So you can choose who can create a proposal within your DAO. You can choose if someone has to approve that proposal before it gets pushed to the DAO. And then you can have, you know, like God mode, where you can veto. If you want to configure this, you can veto a proposal that has been published. Okay, so those are like the different things that you can configure when you're creating the DAO. Each one of these individual configurations can be changed after the DAO has been created. And the way that DAO works is that everything works through a proposal. So if you wanted to make a change to the voting duration, you'd need to create a new proposal to change that voting duration. Same with any of the other configurations. I just wanted to highlight one other, or a couple of other pretty cool things about DAO. Once you've got your DAO set up, you can create things like sub-DAOs, and sub-DAOs are, I look at them as like different organizational units that you can use to either. So you create these sub-DAOs with trusted members, and they kind of have the authority to go and do whatever their tasks are. Now, with this, all sub-DAOs are always ultimately controlled by the parent DAO, so there's no like running away with it, but it's a pretty cool one. We do a validator sub-DAO, so we validate on a few chains, and what it essentially does is we create a proposal for each of the chain proposals, and then as a group, we decide how we want to vote on that chain proposal. And once that proposal passes within DAO, then it pushes our decision to chain. The last thing I wanted to show you was the vesting payments. I think this is a pretty powerful feature. Like I said, there are many, and I can't get through them all right now. But as with everything in DAO, we're going to create a new proposal to create a vesting payment. Oh, that's not what I wanted to do. Sorry. There we go. So creating a new vesting payment. And let me just tidy this up. So you would give your proposal a name and a description, and you'd add an action. Let's do this from the beginning. You'd add an action. Here is our action library. These are all different things that you can create proposals for your DAO to do. And they're all kind of organized in different categories, which is pretty helpful. But we want to work with the Treasury. We want to create a new vesting payment. And what you can do is so with a vesting payment, you choose how much you want to distribute to and to who. And then you can configure how it gets distributed. So this is an example of a linear vesting payment. So it's configured to distribute 100% of the vesting payment over the course of a year, and it will do that in equal steps. But one of the cool things that you can do is you can create steps. So let's just say that you wanted to vest for a year and then release 25% of the payment after a year. You just do it as a second, and we've created our first step. And then we're going to do another year, and we're going to give the remainder of that payment to the recipient. So you can see you can create all sorts of different variations of this. You can see you can do it by the second, minute, hour, day, so on and so forth, and play with it, which is pretty powerful for things, you know, like certainly in the VC world, when you create like founder vesting schedules, it can be completely configured with that. I'm not going to repeat myself, but there's a lot that you can do with DAO. What I would suggest people do is go and play with it. It's pretty intuitive. A lot of it's no code, but it also accepts code if you're so inclined. And you can go to DAO.zone to play with it. And certainly come on to our Discord, which is discord.dowdow.zone if you have any questions. And we're building some pretty cool stuff here. And again, Trevor, thank you for having us.
There we go. Dave, you had to sit here awkwardly for a second. You're like, what are you doing? But yeah, really cool stuff out of DAO. If you guys haven't used it, definitely go and check it out. I think most of us have interacted with it at some point. So if you want to vote or contribute to DAO, go to dorahacks.io/AEZ. Again, the round is still open for the next day or so. And just by casting your vote, you can contribute to DAO, the Go CodeGen project with Surter, the Rollup Company, or Defiant in their indexer, and the other 12 projects that are there as well, and help decide where the 8,000 Atom and the 20,000 USD gets allocated to, in addition to helping out the team. So, Dave, thank you for the time. And the rest of you, I think you're all still there listening. Thank you for your demos today. Don't forget to go and vote. And again, a bad kit is up for grabs for whoever participates in both the QF. There we go. We still have everybody. The QF round and also the Macy voting. So it looks like we still have Dan, Surter, and Dave. Thanks a lot, guys, and we'll see you guys on the next round.
Cheers. Thanks a lot.
All right, Dan, you're muted, but I assume you're saying goodbye.
Oh yeah, sorry. Yes, thank you so much. I enjoyed hearing about all your projects. Have a good day.
All right, awesome. Have a good day, everybody.